Do you want to know a secret? Well, secrets should remain secret. Today, Aurelien and I will explain how you can build applications without ever having to know about the secrets that are going into them. What we want to do when we build distributed modern applications is connect between those components. There are credentials we need to speak to databases, call APIs, and other resources. We also want to make sure that where we do have to use secrets and we're not able to take advantage of IAM roles, that we rotate those secrets regularly. And then we also want to know who's accessing those secrets, where they're accessing them from, and how they're using them. But in my previous job, it wasn't so easy. We used to run an application, and we regularly tried to change the database password. This unfortunately caused a bunch of the different parts of the application to break. And it got so bad that the change control people where I worked wouldn't even let us raise a change to try and change the database password. This is not a great way of using the post-it note mechanism of secrets management. Fortunately, we were very lucky and we didn't get compromised because of not changing these database passwords, but it could have been a lot worse. And the reason we struggled with trying to change the database password and having applications fail whenever we kind of did this is because this is kind of hard. Existing solutions can be kind of complex and costly. Unreliable processes mean that rotation happens and sometimes doesn't happen, then it doesn't get pushed into the application and the application can then have problems and fail, which causes outages and problems for our customers. And because we were also doing support for this application, a lot of us knew what the passwords were for not only the database, but for the application server. And because secrets want to be free, they, like water, they get into source code repositories and post-it notes. We all knew what the passwords were anyway, and this is a really bad way of building and running applications. But who cares about secrets anyway? Well, application developers, we care about secrets because we want to make sure that when our applications run, they can communicate with other parts of the system. We can talk to databases, we can call APIs, we can call third-party services. And the security people that we work with, they care because they want to know that the secrets that we use to communicate between our applications are appropriately protected, secured at rest, have access control applied to them. So really, we all care about secrets. We're all building applications for our customers, and we're all in this together. But putting my security hat on for a minute, there are things that we can learn from the way that we build applications that can directly apply to security. We look at the 12-factor approach to building applications, and many of you use this methodology when you build applications today. And that says that we should separate the configuration from the source code, keep the secrets away from the application. And we can take this approach when we look at secrets management, because essentially secrets is just a special kind of configuration. And the first thing we're going to talk about today to help us keep our secrets away from our application code is AWS Systems Manager Parameter Store. Many of you are already using Parameter Store when you build applications to have contextual configuration pulled into your application at build time, making sure that you've got the configuration for dev and for test and for prod. And you're taking advantage of the hierarchical storage so you can have essentially namespaces and permission that based on the appropriate access. Parameter Store integrates with many of the AWS compute services, Lambda, EC2, and ECS. And it also integrates with CloudWatch, so you can do event-based notification. And because we're thinking about this in a security context, it also aligns with the three foundational security principles of identity, visibility, and encryption. You can apply fine-grained access control over the parameters. You can get logging and monitoring using CloudTrail and CloudWatch. And you can store secrets with secure string, which is backed by KMS to ensure that your data is protected at rest. And the hierarchical mechanism of storing parameters is really useful. So then we create our application code. This is just the business logic that we're interested in. And then, as you can see here, we can have particular credentials for a dev password or a test password or a prod password. So the change that is needed in our application code is minimal as it passes through environments. And ideally, as we pass through environments, we're using automation to build and release our applications. So we're storing our source code in something like code commit, and we're using code pipeline to orchestrate the build and deployment of this application. And when we get to the code build stage, we can pull in configuration from Parameter Store and inject that into our code, so when we deploy our code, it has references to the secrets, and we didn't need to know what they were. We can reference where the secrets are pulled from in our code. Many of you are building serverless applications and taking advantage of SAM to help you do that. And SAM will push out CloudFormation templates, and you can use the same approach. You can refer to parameter store in your CloudFormation, and instead of just referring to parameter store, which is holding secrets, you can use parameter store as a pointer to AWS Secrets Manager, where it can pull the secrets from. So in your CloudFormation, you're using parameter store as a reference. Then when you build your serverless application, the Lambda component of that application can go and pull directly from Secrets Manager the secrets that are required at runtime, which means that you, again, just need to know where to go and get the secrets from. You don't actually need to get the secrets themselves. Using CloudFormation, it's very easy to reference into parameter store. You can create a reference using SSM parameter value and string, and you can then use that reference in other parts of your CloudFormation template. So you can define it once and reference it multiple times. And now, Aurelien, my glamorous assistant here, is going to show how easy it is to use SAM and CloudFormation to manage secrets in your applications. Thank you.
Thank you, Paul. So first, I'd like to show you how your infrastructure as code using SAM and CloudFormation can actually leverage parameter store. So your application better aligns with the 12-factor app methodology. What you have on the screen is the declaration of my serverless application using a SAM template. In the lower part, you have the creation of my Lambda function and its association with API gateway. And highlighted in blue is actually the creation of a parameter store parameter. Now, what's really interesting here is for the parameter store parameter, neither the name nor the value is actually hard-coded. If we scroll a bit up, the way it works is I reference some parameters that I can later reuse at the time of the deployment. If we go back to the Lambda function, we can see highlighted in orange-ish that we're actually referencing the parameter store parameter. So you deploy your SAM template inside CloudFormation. You provide all the necessary parameters for the template to deploy correctly. And what you expect being deployed in your AWS account is a set of new resources. The very first one that you will find is a new parameter store parameter, and that's the management console for parameter store. If we scroll at the bottom, we can see here we have a new parameter. It has a name, and down at the bottom, we have a value, which is a string that contains some JSON information. So when you use parameter store, SAM, and CloudFormation, that allows you to have a more secure and more flexible application. And that's very much one way to leverage parameter store. But there's actually another way that we see very often from customers. That way is actually to use the command line. And typically, you have a shell script. You do some custom work. Maybe you have some unit tests that you've integrated inside your CI/CD pipeline. So what you have on the screen here is actually a CI/CD pipeline using code commit code pipeline. So when you push your changes, code pipeline is going to be triggered. There's a code build happening with any custom logic that you need to do. And finally, the deployment happens at the bottom. So let's have a quick look on what it takes to actually get the parameter from the command line. It's actually very simple. As you can see here, I called the AWS CLI. SSM is the name of the main service, and I call get parameter. Now, what Paul mentioned is some of the parameter store can have different types, one being a string, but you can actually protect your parameters in parameter store using encryption. When you do so, make sure that you actually provide the parameter -- with -encryption, as you can see here. And then the last argument is actually the name of your parameter. What you have as an output is actually the raw output from the service. The first field is the version, so parameter store supports versioning of your parameters. So whenever something happens, you have the ability to look back in time inside your parameters to understand the previous values and if there's anything interesting to you. The type in this example is actually a secure string, so I use KMS as a way to protect the content and to make sure that everything is encrypted. And the last one, which is the most interesting to us, is actually the value where you have the JSON payload. Now, when you have shell scripts, it's sometimes a bit tricky to read JSON, and especially when it's an escaped string inside another JSON payload. So one way to actually make things extremely simple is to use the JQ command line. And that's going to extract us just the relevant bits and pieces that we can later reuse in our own scripts. So something important here. We see everything is actually working, and it looks pretty cool. Keep in mind that this demo is actually working because my EC2 instance has the necessary role and IAM permissions to query both parameter store as well as KMS. If you're missing the necessary permissions, your secrets and your parameter store parameters won't be accessible for your applications or any operational people to actually access to. So as I said, I use code build as a way to build my application, and part of that, I want to do some unit tests. That's actually quite cool. And part of code build, the way it's being done is you need to provide a build spec file in which you define different phases and different command lines. What I highlighted in blue here is actually the way I call my unit test through the Gradle application. Now your applications run, it will output a number of information, and that's going to be stored in CloudWatch. But to make things a lot easier for you to actually consume, through the code build history, you have the ability to read the output and see exactly what happened. So that's what I use to build my application. And down at the bottom, we have the build logs. As you can see, that's exactly what I just showed you using some custom shell script. And I'm just outputting information before running my own unit testing. So really, parameter store is a great way for you to separate your code from your runtime information and configuration, and it's actually extremely easy.
Thanks, Aurelien. It's great to see how easy that was. And just to recap on some of the early part of this, this is all you need to do to define a resource in CloudFormation that's pointing to parameter store that's going to say where we're going to go and get our secret from. And then you can refer to that later on in your CloudFormation code. And I also like the fact that we have unit tests in there, because unit tests can include security tests, because security testing is part of functional testing. Test early, test often. And we move on to AWS Secrets Manager. And this is a service that allows you to do safe rotation of secrets, store secrets securely backed by KMS, and also integrate with RDS, some databases that you can install on top of EC2, and you can extend it using Lambda to talk to other services that you may have in your environment. You can perform on-demand or scheduled rotation of secrets and with a configurable timeline, and it has versioning. So if a rotation isn't successful, it will roll back to the previous version, so you always know which version of a secret is being used for a particular resource. And again, it aligns with those 3 foundational security controls: identity, visibility, encryption. When you create a secret, you choose which encryption key, either the default key or customer managed key that you want to use to protect that secret, and it gives you an extra level of protection because you will need IAM permission to the KMS key in order to read the secret. So remember in my previous job where we had a hard time managing secrets in our database? So we needed to connect to the database from application code. Maybe somebody from the database team had created those passwords, put it into, hopefully, Secrets Manager if we had it, but it seemed in our previous environment writing it down in Post-it notes. When we deployed the application, it would be nice if we could have deployed it into an IAM role so we could use that to authorize connection to AWS services like Secrets Manager. And then when the application starts, what would have been great is if it could bootstrap and get access to secrets at runtime, so we wouldn't have had to manage them in a different way. So the kind of architecture that Aurelien's going to talk through in a moment looks a lot like this. So you've got your code. He's written some Java code, but your code as appropriate. This runs on top of an operating system that runs on top of an EC2 instance that gets its credentials from an IAM role. We have some AWS resources and some other resources that we want to connect to as part of this application. In the AWS resources section, we have AWS Secrets Manager, where the database credentials have been loaded. The application, inheriting the permissions from the EC2 instance it's running on, is authorized to call AWS Secrets Manager, which then returns the credentials to the application, which is able to connect to the database. We can then set up our rotation, so these credentials are periodically rotated. And as I mentioned, if the rotation fails for some reason, the versioning that's available in Secrets Manager allows it to roll back to the previous version. And additionally, what you can do within your application is you can check to see if there's been an authentication failure to the resource, the database in this particular instance, and make another call to Secrets Manager to go and get the updated credentials. This means that you can keep your applications running and you're not delivering outages to your customers when you implement security by rotating your database credentials. So Aurelien, show us how you built your application and how easy it was.
Thank you, Paul. So first thing first, how difficult it is to actually create a secret in Secrets Manager. What you have in front of you is the Secrets Manager management console. You click on Store Secrets, and we provide you with 3 different use cases. The first one is we allow you to store secrets as a key value pair. You can store any arbitrary information. The second way is you have inside your EC2 instances your own database, and we provide you with some templates to actually integrate with any of these databases. But the most common use case that we see from customers is when they have their databases running on RDS. So that's what I'm going to show you today, how it integrates together. The first thing that you input is your username, and that's already provisioned inside your RDS database. So typically, that would be your operational people or your DBA. Then you provide a secure password that's you already provisioned. So I'm French, and I'm pretty sure by now you all know that. So in my passwords, I like to add baguette just for extra flavors and crustiness. And more importantly, the next step is you need to provide an encryption key, a KMS encryption key. By default, that's the default service encryption key. But you have the ability to provide your own KMS encryption key. What's actually really cool is because you provide your own encryption key, that gives you additional control against what resources or which person in your organization has the ability to consume your secrets. The next step, you select your RDS database. You click Next. You enter a name for your secret. And on the third screen, that's something that I really, really love. You can enable automatic rotation of your secret. So by default, you see on the screen that's 30 days. OK, 30 days, that's much better than what we used to do in the past. I mean, personal experience, I've seen 10 years plus of passwords and secrets never being changed. But hey, why 30 days? Why not actually 1 day? I mean, literally, there's nothing preventing you from doing that. We have now a central place where we manage all our secrets, and our applications should actually consume that service, Secrets Manager, to fetch the up-to-date version of the secret. So I'm setting 1 day here. The last screen gives you the ability to review all the details, and then finally, you click Store. It takes a minute or two, so for the sake of this demonstration today, I've already provisioned a secret in Secrets Manager. What we have here, again, is encryption key for my secret. If we scroll a bit further down, we can see we have the rotation enabled, and it happens every day. But more importantly, the rotation of that secret is actually done by a Lambda function here. Now, the service provisions that inside your AWS account, you have access to the source code for you to review, to modify, play around as much as you want. But there's a real implication to that, and it's actually where the true powers come. You can integrate Secrets Manager literally with any services, whether it's your own APIs, with any third-party providers. There's absolutely no problem with that. I'm pretty sure that many of you have seen today Jeff Barr in the crowd. He has purple hair, really nice person. Please talk to him. A few weeks ago, he posted an article on the AWS blog around how you can use Secrets Manager and Lambda to rotate your API, your Twitter API keys using Secrets Manager and Lambda. So literally, you can integrate with anything. Now, because I have the necessary permissions for me to use Secrets Manager, I can actually retrieve the details of my secret. In terms of data, everything is stored in JSON, and you can actually customize the JSON to match what your Lambda function is doing. There's absolutely no problem. So that's very much what it takes for you to create a secret in Secrets Manager. But now you need to do that extra piece of work, which is the interaction between Secrets Manager and your application. Again, we love what developers are doing, and we like to help as much as we can. So part of the console, we provide you 4 sample code. One for Python 3, C#, JavaScript, and Java. What I'm going to do today is I'm going to show you just how easy it is to literally copy-paste that code into my Java application, and we'll see how that works. So let's do a quick copy-paste here. Let's open the code. So I already put some tags so I can remember where to paste everything. So before I go actually a bit too much into the code here, back to the 12-factor app methodology. As you can see here, I have 3 lines of code that are actually reading information from the environment of my operating system. So again, no hard-coded value. Let's paste the code. And for you, the most important line that's worth knowing is this one, client.getSecretValue. Once you've done that and you haven't had any exception, we can look into the code and we can see that I'm just feeding that information back into my code. Let's save the code, And what I'm going to do next is actually, one, build the application, and second, I'm going to run it. So while this is doing it, let's have a look at the code itself. I have an infinite loop. My code tries to connect to my RDS database. If it works, great. We pause for 3 seconds, we disconnect, and we do it again. That's typically where you insert your business logic. Otherwise, we request Secrets Manager to actually give us the up-to-date version. So as you can see here, in the shiny colors, we have the details of our secrets. And the application, every 3 seconds, reconnects to the database as a proof to, hey, we have the right credentials, everything is working. Now there's something that people who go on stage are really, really scared. Typically changing a password live, okay? And if you ever try to do that as well on your database, probably like me and like Paul, something is usually likely to break. So I'm going to show you actually how powerful Secrets Manager is, because I'm going to just do that in front of you. So from the console, you can select Rotate Secret immediately. And when you do so, the service is going to invoke our Lambda function that I just showed you before. That Lambda function connects to the database, changes the password, and updates Secrets Manager. Now what's going to happen is my code doesn't have the up-to-date version, so the connection is failing. What it does is then ask Secret Manager, please give me the newest credentials, which is now displayed on the screen, and then the work can literally resume without any interruption. So really, using Secrets Manager is a great way for you to separate, again, your code from the runtime configuration, and especially your secrets. That's literally that easy.
Thanks, Aurelien. If only you were about when I was doing my previous job, we wouldn't have had the problems that we had. So we've got a great solution for managing secrets, keeping our applications updated. But if you're not logging, it never happened. If I put my security hat on, what we need to make sure is that we demonstrate that we are rotating secrets daily, because it's now trivial to do so. So it's really great to know that both Parameter Store and Secrets Manager log APIs in CloudTrail and have the ability for you to pull out particular events using CloudWatch events and send them to people. You may be particularly keen on knowing when secrets are deleted or if secrets are rotated. And logging is one of the things that are important in the way that we think about cloud security in AWS. And you may have seen this slide before, and it describes the security perspective of the Cloud Adoption Framework. And they're in a particular order. And it's worth looking at this order when we talk about how we think about secrets management and the management of credentials. We start off with identity and access management. And we talk about how we can apply fine-grained permissions using IAM to Parameter Store, to KMS, and to Secrets Manager to make sure that only the right people have access to those secrets. And then we move on to logging or detective control, where we see what's going on by looking at CloudTrail and triggering alerts. And then the third pillar that I talked about, data protection, using KMS and Secrets Manager to actually protect your secrets as you pull them into your application. So we saw today, or Aurelien demonstrated, how easy it is to build applications without any knowledge of the secrets that are required to connect to the other components that you build. You can securely store, access, and audit access to secrets using Parameter Store and Secrets Manager. You can use the serverless application model in CloudFormation to talk to Parameter Store, build serverless applications, and pull in parameters as you build these applications. And you can integrate into the way that we build applications using source control, pipelines, and code build. So let AWS do what we're really good at, and that's doing the undifferentiated heavy lifting. So you can focus on building amazing applications for your customers. Use Parameter Store, use Secrets Manager, and secrets will remain secret. Some additional information here, and if you tap your badge on the way out, you'll be able to get more information. And as ever, please rate the session. Your feedback is important to us, and it helps us build more great sessions for you. Enjoy the rest of Dev Day. Thank you.